Hi everyone. Let's continue the exercise. In this part, we will couple the AMI boundaries and create the interface. Hold Ctrl and click to select both AMI boundaries, then right-click one of them. Click Create Interface. Now the interface between these two AMIs is created. Nothing else is required here. Now let's verify that the boundaries are assigned correctly. Make sure the boundaries are applied properly. On cylinder minus cube, we should have a wall boundary, a symmetry boundary, and an AMI boundary. Good. Cylinder boundaries are correct. For the background domain, we also have an AMI boundary, plus the inlet boundary, the outlet boundary, and the symmetry boundary. Okay. Another thing to check is the physics assignment. Let's confirm which physics continuum each region is using. In my case, everything is under physics 1. For cylinder minus cube, I can open physics values and check motion. At this stage, it is still stationary. Now we need to create a mesh for this region. Right-click Mesh, choose New, then Automated Mesh. Select Cylinder minus Cube, enable Surface Remesher and Polyhedral. And also turn on Prism Layer. Let me resize the window. We only need Prism Layer here. And we can leave the rest at default. Click OK. Under Default Controls, set the base size to 0.1 meters. Then right-click the mesher and execute. The mesh is created. Now I want to add it to the scene. Go to Mesh Scene 1, then Mesh 1, then Parts. As you can see, the regions are not selected yet. So I select all of the regions. Let me fix the view. Z plus with Y plus is up. Now zoom in. And you can see how the meshes look. Another point. For overset, we said, the overset region and the background region need refinement. So we get a smooth transition from overset to background. For AMI boundaries, it's similar, but the key is that the AMI faces must have a good mesh. We don't need to globally refine everything. One workflow I usually use is this. I already defined a cylinder part in my geometry, and I used it in this setup. For AMI, I duplicate that cylinder and name it cylinder fine. Then I slightly increase its dimensions. Just a little bit bigger. For example, from radius 2.5 to about 2.75. Then I use this larger cylinder to refine the background mesh around the AMI. In the background mesh, I create another custom control. Right-click, New Volumetric Control, and assign it to the cylinder. Give it a clear name. The one above was for overset. And this one is for the AMI cylinder refinement. I name it Cylinder Refinement. Click OK. In Controls, set surface size to provide and enable surface meshing. And for volume size, set it to absolute. The value should be 0.1 meters. Now let's execute again, and I'll click outside to refresh the view. Now you can see the mesh around the AMI boundary is much finer. Since I enabled surface meshing, the AMI surfaces were meshed as well. So now the mesh quality should be good across both sides of the interface. Next, go to Tools and open the Motions folder. Find Motions in the list and open it. One important note, with this AMI setup, we cannot use translation. We can only apply rotation because translation would move the AMI boundary. This approach is ideal for rotating machinery, like propellers, rotors, and similar cases. Now I right-click Motions, choose New, and this time I select Rotation. Rotation is selected. Let me expand the window so we can see the options. Here is rotation rate. I set a value in rad/s, just as an example. The rotation axis should be along z. The origin is 0. One more important point. In the rotation properties, you can choose a coordinate system for the axis location. And here you choose how rotation is defined. I keep rotation rate as the specification, but for coordinate system, I change it from laboratory to my Cartesian. So the rotation is defined about the shifted cube location. Axis is still z, and the origin is 0. And 0 in my Cartesian is exactly at the center of the second cube. Great. The rotation motion is set. Now I go back to Regions. Open Regions. Select Cylinder minus Cube. In Physics Values, Motion Specification is currently stationary. Now we also have rotation available. Select Rotation, and the motion parameters are applied. Now I zoom in, initialize, and click Run. What I expect is, the second cube rotates in place around its own axis, and the first cube should also rotate and move upward, like in the previous setup. We can check this under rotation and translation as well. As you can see, for the first cube, we saved the rotation state from the end of the previous exercise. So here we mostly expect translation. I can pause, advance one step, then update rotation, and apply the rotation I want. For example, set rotation to 10 radian per second and update translation here as well. I switch translation back to the sinusoidal sine and cosine form and bring it back to a harmonic motion. Now I also convert rotation to a harmonic form. Set it to 10 times. Cosine, with 30 times time as the argument. I select time from variables. I can also apply the same idea to the axis direction to make the motion more interesting and easier to visualize. I apply it on the axis direction too. Click OK, then OK. Now rotation is defined. Let me set both rotations in rad/s. Now the first body has rotation and translation, and the second body has rotation only. Now I clear the solution again and restart from the beginning. I initialize again, and I switch the projection mode to parallel view. The setup is fully done now. You can run the case and see how it develops over time. In the next video, we focus on post-processing the results.